Imagine you're pointing humanity's most powerful telescope into absolute emptiness. To a place where, as scientists thought, there was absolutely nothing. And suddenly, this emptiness starts to respond. Thousands of galaxies, some of them billions of years older than Earth. And then a new telescope comes along and sees even stranger objects. Too bright, too massive, too early to even exist. And here comes the question that still keeps scientists up at night. Are we misunderstanding the universe? Or is it behaving in a way it shouldn't?
In the mid-90s, space researcher Robert Williams was about to take a step that his colleagues considered very unwise. He wanted to point the Hubble telescope for 100 hours at a part of the universe where there were no even remotely notable objects. Other astronomers thought it was an irrational waste of resources and time for such a valuable research instrument. However, Robert Williams did it his own way. He was the director of the Scientific Institute and could freely allocate 10% of the telescope's observation time. The researcher promised that if he didn't find anything interesting in that area, he would step down from his position. So, from December 18 to 28, 1995, the Hubble telescope began observing the area near Ursa Major. This is only 1/30th of the width of Earth's satellite. As a result, we obtained 342 images of this area. It turned out that there was a huge number of galaxies in this area. Their number reached 3,000. Some of them were as old as 12 billion years. Galaxies of completely different types were observed. Both elliptical and spiral, blue, orange, red, yellow. The image with various galaxies began to be called the Hubble Deep Field. This discovery was a real miracle.
Hubble.
It was not the end. The research continued. Scientists wanted more data about this area, and almost 30 years later, the James Webb Telescope took on this mission. The first part of James Webb's mission began in mid-2022. For a long time, the telescope searched for galaxies in the early universe across separate regions of the vast cosmos. Scientists expected to get images of different versions of the Hubble Deep Field, and no one assumed that this time they would be able to find something extraordinary. However, the result exceeded all expectations. The researchers immediately detected galaxies that formed just 200 million years after the Big Bang occurred. It could be confidently stated that the James Webb Telescope has lifted the veil of mystery from a previously little explored period in the development of the universe. Nevertheless, there were features in these galaxies that scientists had not suspected. The brightness of these objects was very high. They contained stars totaling billions of solar masses. Galaxies of such enormous size do not fit into our ideas formed by the standard model of the universe's development. Did scientists make mistakes at the time? Or is there another explanation for what James Webb discovered? And most importantly, don't the newly discovered data refute the Big Bang theory? And to have a complete understanding of the situation, let's delve into earlier ideas about how the universe was formed. During the first second after the Big Bang occurred, the four fundamental forces separated from each other. These are gravity, electromagnetism, as well as the strong and weak nuclear interactions. At that time, the universe was a hot mixture of primordial particles. After that, in the next 3 minutes, the temperature of the cosmos decreased and expansion occurred. At that time, helium nuclei were formed along with other fairly light elements. After 400,000 years, the universe cooled down enough for the first atoms to form. The first stars appeared after 150 million years. These were huge stars that we call population 3 stars. В их составе преимущественно гелий and hydrogen. Clusters of gas and the first protogalaxies formed around such stars. They interacted with dark matter. Through gravity, these galaxies merged into a single whole and formed larger galaxies. All of this happened over the course of about 1 billion years. As we already mentioned, the data obtained from James Webb calls this version into question. Scientists claim that we would have detected a huge number of parts of protogalaxies that have not yet merged with each other. However, we observe objects that can be considered large galaxies. We include GLZ-13 among such galaxies. Its redshift is 13.1. Redshift is a parameter by which we determine how much the universe has expanded. The greater the redshift, the higher the speed at which the object is moving away from us. Galaxies with a redshift greater than 11 have been discovered only very rarely. The Hubble telescope, while carrying out its work, found one such galaxy. With James Webb, it's a different story. Since it's an infrared observatory, the device can explore more distant regions of space. Looking at the redshift value of GLZ-13, the galaxy formed within the first 300 million years after the birth of the universe. Initially, the redshift was estimated from photometric observations, that is, using different color filters. The data from such observations could be inaccurate, especially regarding the exact value of the redshift. Observations using the Atacama Large Millimeter Array showed that the galaxy does indeed have a redshift, but its value is about 13. The mass of GLZ-13 is a billion solar masses. This contradicts the generally accepted models of star formation. If all the available components participated in star formation, the size of this galaxy wouldn't be so enormous at such an early stage. Even if we assume that stars formed so quickly and increased their mass so rapidly, then why don't we see anything like this in modern galaxies? It's quite difficult to logically justify this based on the generally accepted lambda-CDM cosmological model. As you can see, here lambda stands for dark energy and CDM stands for cold dark matter. Scientists are trying to explain the data obtained by James Webb using one of the cosmological models. For example, the lambda-CDM model. Some researchers claim that the accumulation of huge masses during star formation is characteristic specifically of the early universe. The gas pressure and temperature are high. These factors influence how star formation occurs. There is a theory that magnetic fields formed earlier than previously thought, and it was their influence that accelerated the movement of particles, which resulted in such efficient star formation. The researchers have another hypothesis. It is quite possible that the brightness of galaxies is so high because, in the early stages of the universe, the amount of cosmic dust was minimal. The data from James Webb can also be integrated into the rather controversial idea of modified Newtonian dynamics. According to this model, dark matter does not exist, and the probable traces of its existence can be explained by gravitational fluctuations. There are aspects in Webb's observations that can be explained using this model rather than the lambda-CDM model. Even though the telescope has detected galaxies whose existence contradicts generally accepted cosmological models, this does not invalidate the Big Bang theory. This theory was created based on a huge amount of observations. We can't just disregard their existence. For example, the Big Bang helps us determine how much of each element existed in the universe in its early stages. When studying old galaxies, the amount of each element in them is checked against the Big Bang theory. The Big Bang model also matches the redshift observed in more distant galaxies. As the light from distant galaxies reaches Earth, we see that it is greatly stretched. Its red color is more intense than it should be. This is a result of the galaxies being far away from us. From numerous observations, we can conclude that in the universe, virtually all objects are moving away from each other. In the early stages of the universe, everything was much closer together. The Big Bang theory also supports this. The most convincing evidence of this is the cosmic microwave background, which was formed after the Big Bang. The theory about it was developed in 1948 and it was discovered in 1965. What the James Webb Space Telescope discovered beyond our galaxy proves that widely accepted theories need to be re-examined. The Cosmos Webb program is about to launch soon. It is expected that with its help, we will see more early galaxies by expanding the observation area. Thus, we will get a broader observation base, which will help us improve established models of star formation. The James Webb Space Telescope can radically change history.
Human vision is of little help in studying distant worlds. That's why inventors on Earth have been creating spyglasses and telescopes for centuries, whose eyepieces, defying vast distances, helped us peer into the depths of the universe. Over time, scientific progress made it possible to send spacecraft equipped with cameras to the surfaces of planets in the solar system. Thanks to them, we were able to see with our own eyes mysterious craters, unexplored valleys, rugged cliffs, and other details of alien landscapes. Mars is the favorite when it comes to research. It has had more Earth visitors than any other planet. So what did they see on this barren, gloomy, yet so alluring planet? Before you is a unique collage of Martian images taken from the catalogs of various missions that have ever visited this rocky celestial body. Let's start with the titanic structures. This image was assembled from dozens of pictures taken by Curiosity's massed camera. It was taken on the 1931st Sol in January 2018. Mount Sharp stands in the center of Gale Crater, which has a diameter of 96 miles. Would you like to take a closer look at Mars on a microscopic scale? Absolutely. This photo shows Martian thin-layered rock, which includes tiny crystal-shaped bumps, as well as mineral veins with bright and dark material. And in this case, it shows how to highlight the desired object using the standard tools provided by the scientific equipment of the probes. The image demonstrates how using special filters available on the mass camera of the Curiosity rover helps to detect the presence of certain minerals in target rocks. The image is a combination of photographs taken through 3 filters, chosen so that hematite, an iron oxide mineral, stands out as an exaggerated purple. Here is Curiosity conducting tests on October 17, 2017, as part of the team's development of a new way to use the rover's drill. This image shows the drill touching the ground during the evaluation of measurements by the sensor on the robot's arm. This image from the chemistry and camera instrument on the rover shows Vera Rubin Ridge, sedimentary layers, mineral veins, and the effects of wind erosion. Martian landscapes are an inexhaustible subject for cameras aboard space probes. Here, for example, is a view of Vera Rubin Ridge from below on Sol 1734. This location was marked for the Curiosity rover even before the spacecraft landed in 2012. And here is another view of Vera Rubin Ridge on Mount Sharp on Mars. The structure is located right above the reddish rocks of the Murray Formation. This image shows a dark hill called Irizon Hill, which rises about 16 feet above the layered, exposed red materials covering the slopes of Mount Sharp. Here's a map showing the route taken by the Curiosity rover from the location where it landed in August 2012 to its position in July 2017. Sol 1750 as well as the planned route to additional geological layers of Mount Sharp. Do you think there are no dunes on Mars similar to those on Earth? You're very mistaken. Take a look, Nathan Bridges, a dune on a Martian mountain. It was one of the research stops for the campaign studying active Martian dunes. Bridges' 1966-2017 helped lead this mission. And here's another panorama with an active linear dune in Gale Crater. And here are the textures that Curiosity rover studied on the Martian dune. This image shows ripples at 2 different scales. Editor. There are also unique whirlwinds on the red planet. Dust devils dance in a sequence of images taken on February 12, 2017. A dust devil passes near a Martian sand dune. Take a look. A Martian dust devil in Gale Crater. Sol 1597. This pair of images shows the effects that occurred in a single Martian day. The photo demonstrates sand blowing under the rover's underside. And this photo takes us back to Mars's ancient past. This network of small polygons on the surface of a Martian rock near the right edge may have formed as a result of cracks in drying mud more than 3 billion years ago. And in the foreground, you can also see purple-tinted rocks near the rover's location at the end of 2016 on Mount Sharp. Would you like to take a look at the iron-nickel meteorite that was struck by the rover's laser on October 30, 2016? It is worth noting that the dark stone with a smooth surface was meticulously examined using laser pulses and confirmed to be an iron-nickel meteorite. This is a 360-degree panorama from the rover on Mars. This is exactly what our gloomy neighbor looks like. This self-portrait of the Mars rover shows the vehicle at the drilling site called Quella in the Murray Buttes area on Mount Sharp. And in this shot, the moment of truth is captured. The chart shows the locations where the Mars rover collected its first 18 rock and soil samples for analysis by laboratory instruments. They are drilling M9A in Murray Buttes on Mars. The top of the hill in this scene from the mass camera is about 5 meters above the rover and 25 meters southeast of it. Do you want to see pictures from the Farewell to Murray Buttes series? Here they are. In this photo, you can see an outcrop of a hill with layered rocks in the Murray Buttes area on Mount Sharp. By looking through all the images shown, a person who has never been to Mars can get a general idea of what landscapes await the colonists who dare to settle on the red planet. Not a very hospitable landscape, is it? And the weather isn't pleasant either. There's only one consolation. Perhaps after thousands of years, we will be able to terraform our dusty neighbor, turning it into a clone of Earth. So until that happens, hurry up and enjoy the authentic Martian landscapes. What do you associate with India? An unexpected question on a channel about space, isn't it? But that's only at first glance on the surface. For many, India is the free-spirited state of Goa, with its gentle Indian Ocean and eternally high hippies. For the younger ones, it's Kipling's stories about Mowgli and Rikki Tikki Tavi, while the older generation, wiping away a tear, remembers the heartbreaking song from the movie Zita and Gita. But today, we will talk about India in a completely different context. It turns out that the country of elephants and sacred cows has become the only nation on the planet to send the cheapest interplanetary mission in the history of space exploration to Mars. Somewhere, as this phrase is being said, Elon Musk is feeling a bit sad. The Indian government invested 125 crore rupees in the development of the spacecraft, which is equivalent to $23 million. Overall, the project cost about $74 million and was completed in just 15 months. Checkmate Europe and America. Mangalyaan. The name of the Indian probe that has been successfully operating in orbit around the red planet since September 24, 2014. Mangalyaan means Martian probe. Obviously, the Indians decided not to bother too much with the name of the spacecraft. Amazingly, Mars Orbiter mission, which is the international name for Mangalyaan, has set yet another record. It became one of the few spacecraft to enter Mars orbit on its first attempt. Before that, only the European Space Agency had managed to do this. The thing is, the Red Planet is known for its notorious treachery. Almost all the probes on its surface and those flying in orbit as artificial satellites experience failures from time to time, but not Orbiter. It still collects information about the planet and has managed to send many amazing images of Mars back to Earth. But first, let's talk about the probe itself. Mangalyaan is 1,337 kilograms of useful equipment and fuel. Out of this mass, more than 850 kilograms is fuel, while the weight of the instruments is negligible, only about 15 kilograms. The spacecraft is equipped with a liquid-fueled engine, solar panels, and a number of gadgets necessary to accomplish the objectives assigned to this mission. Here are some of them. MSM, and spectrometer for determining the concentration of methane in the atmosphere of Mars. As is known, its presence indicates the possibility of organic life existing on a celestial body. LAP, a 2-kilogram photometer, is designed to assess the hydrogen loss from the atmosphere of the red planet. MENCA is a relatively large instrument that studies the most rarefied part of the Martian atmosphere, the exosphere. TIS is an infrared radiometer that helps to map Mars and its interior. MCC is a color optical camera equipped with multiple filters. It is thanks to this camera that Earth astronomers receive such detailed and clear images. Considering the useful equipment of Mangalyaan, we can determine the objectives pursued by the probe as it orbited the red planet. First and foremost, the spacecraft studied the atmospheric layers of Mars and its mineralogical composition. In addition, the orbiter examined the details of the Martian surface in detail, and the Indian probe accomplished all these tasks excellently. It is worth noting that the presence of an advanced onboard computer, sometimes it feels like you have to pinch yourself to believe it, turned Mangalyaan into an autonomous interplanetary station capable of solving most problems on its own. So, what did the probe see on Mars? It managed to observe many things that even the much publicized NASA spacecraft couldn't observe. Let's start from the beginning. The indicated image shows the Patal crater. This 40-kilometer wide crater is located in the Ophir Canyon, named after a legendary land filled with gold and jewels. But the Martian region with this name isn't exactly luxurious. It's just a barren, rocky part of the giant wound on the planet's surface known as the Via Marineris. The Ophir Canyon, which is part of the giant network of craters and gorges, was photographed by the orbiter from a distance of 1,857 kilometers, and the photo clearly shows how steep and sheer its walls are. The depth of the feature is about 10 kilometers, and its length is over 300 kilometers. Valles Marineris itself was also captured in photographs by Mangalyaan. This complex system of labyrinths and craters stretches for 4,500 kilometers, which is a quarter of Mars' circumference. The width of the giant canyon is 600 kilometers, and its depth reaches up to 11 kilometers. Essentially, it's a land-based Mariana Trench. In this image, you see a three-dimensional projection of Valles Marineris. The spacecraft also managed to observe some impressive Martian craters, such as the huge impact crater located near Huygens.
467 километров.
These are 467-kilometer-wide ancient pits that appeared here in times immemorial. The orbiter's camera also captured images of the Gale and Coma solar craters. The portrait of our dusty neighbor would be incomplete if the probe hadn't sent back to Earth a picture of the highest mountain in the solar system, the magnificent Olympus Mons. In this photo, it's difficult to make out the details and imagine the true scale of the mountain. But notice that compared to it, the neighboring cliffs seem like pale imitations of hills. In the 3D photo, the power of Olympus is felt much more clearly. This Martian mountain is a long-extinct volcano with a height of 26 kilometers from its base. If you compare it to the largest volcanoes on Earth, it makes you uneasy. Its diameter is 540 kilometers. Not every part of the Earth can boast such dimensions. The caldera alone reaches 85 kilometers. At the summit of Olympus, there is practically no atmosphere. It's almost a technical vacuum, and the pressure is only 2% of the surface level. For comparison, on Everest, this figure is close to 25%. But let's turn to objects that seem smaller against the backdrop of such diversity. For example, the Mangalyaan probe managed to capture a unique moment of the tiny Phobos passing against the giant backdrop of Mars. You have to admit that's a worthy backdrop for a rocky little bug. And here's another remarkable shot: the shield volcano Argia. The diameter of this mountain, located southwest of Olympus, is 435 kilometers, and its height is just a little less than Olympus itself, 19 kilometers. Moreover, the caldera of Argia is even larger. Its width is a whole 110 kilometers. It is believed that the mountain is riddled with grottos that appeared after massive collapses. By the way, here is the same Argia, but this time surrounded by water vapor clouds. Could it be that the orbiter has only been photographing details of the planet all this time and has never taken a picture of it in full? Of course, there are also full portraits of Mars. Here you can clearly see the ice cap of the celestial body nestled at one of the poles. And in this photo, you can see the planet's atmosphere. But everything comes to an end eventually. We're leaving the Indian mission, which clearly proved that it's not just Europe and the US who still have what it takes. If any of you wondered why a poor country drowning in garbage needs this probe, here are the words of one of the Indian officials. We often hear arguments that a poor country doesn't need a space program and can't afford it. But if we didn't dare to dream big, we would still be a nation chopping wood and drawing water. India today is too great to remain on the sidelines of high technology. Have you ever wondered how long you would like to live? 80 years. 90, 120 longer? Will you change your mind after you reach that age? 50,000 years ago, most people died young. As skills and resource use and medicine improved, the situation kept getting better. Today, people live longer and healthier lives than ever before. But all of this has unforeseen consequences. We spend an increasing part of our lives being sick and in need of care. Most of us will die in a hospital bed, which is depressing in itself. But we also see this happening to those we care about. But perhaps we can stop this for good. The most effective way to treat a disease is to prevent it. You can save many more lives if you convince millions of people to stop smoking, compared to creating a better cure for cancer. So why not put an end to what causes all diseases in the aging process? In a nutshell, aging is caused by physics, not biology. Think of a car. Parts wear out from friction. Metal parts rust. Filters get clogged, rubber cracks. Our bodies wear out from trillions of tiny physical processes: oxygen, solar radiation, metabolism. Our bodies have many mechanisms to repair this damage, but over time they become less effective. Because of this, our bones and muscles weaken, our skin wrinkles, and our immune system becomes weaker. We lose our memory and our senses deteriorate. There is no such thing as death from old age. We all die because one of our vital parts breaks down. The older we get, the more damaged and fragile we become, until one or more diseases kill us. Unnoticed by most of us, research on extending life has made unprecedented progress in the past few years. We have begun to understand the mechanisms that cause aging and the algorithms to control them. Aging is not a mystical process, nor is it something we can somehow avoid. It is possible that humanity will be able to halt the progression of aging, so to speak, to postpone its onset. Now let's try to look at this phenomenon from a scientific perspective. And in another video, we will look at the actions of modern scientists to delay the onset of aging. The first question we need to answer is, should we even try to stop the aging process? And is this actually a good idea? Extending life or ending aging will cause certain discomforts for a large number of people. Every person is born and gradually goes through all the stages of life: childhood, adolescence, adulthood, old age, and death. Throughout human history, this has been considered the most natural process. So it follows that aging is a logical and good process, right? We like the idea of living long enough to experience all the nuances of old age. These are the so-called golden years. But the reality isn't so straightforward. Many people look forward to this period of old age, but no one wants to feel old. Let's, for example, recall the Greek myth of Tithonus. Tithonus was the lover of the goddess Eos and was probably an amazingly young man, because the goddess asked Zeus to grant the young man immortality. The goddess wanted to spend eternity with him, but Eos forgot to ask Zeus for one more thing: eternal youth. Zeus granted Tithonus eternal life, but he grew old and simply couldn't die. After living for several hundred years, Typhon became utterly decrepit, shriveled up to the size of a grape, and remained in that helpless state forever. Since those ancient times, people have been afraid of the concept of endless old age. In fact, the process of ending old age does not mean that a person should gradually become weaker and weaker. If you stop the aging process at an advanced age, it will already be too late. For example, a person who managed to stop the aging process at 90 years old will die within the next few years anyway. His body has already suffered a lot of damage, and he simply won't have enough physical capabilities and resources to recover. At an advanced age, there are more chances of developing critical illnesses. According to scientists, the concept of life extension is directly proportional to prolonging the period of illness. Therefore, we are seeing the end of the idea of a fixed maximum for life extension. No one can say for sure how far life can be extended. It may be possible to achieve a lifespan of up to 120 years. Or maybe humanity will be able to overcome aging and death forever and completely get rid of all diseases. At the moment, it's difficult to assess all the potential possibilities of humanity. Yes, maybe it will be possible to achieve complete immortality. But does humanity really need this? Actually, the concept of life extension is just another medical term. All the actions of doctors are aimed at extending life and minimizing suffering. A larger percentage of healthcare resources are directed at the consequences of the aging process. Most of a person's resources throughout their life are directed toward healthcare, with half being spent during old age and approximately a third of the resources in middle age. Currently, a large number of medical trials are being conducted aimed at extending life through the use of medical techniques. But so far, this has not shown any effectiveness. All attempts to prevent or stop the aging process are just as natural as organ transplants, the use of vaccines, antibiotics, or treating cancer with chemotherapy. Nowadays, everything that at first glance seems unnatural is considered normal. We have learned to enjoy high standards of living and to strive for more. But most people start thinking about preventing old age when it's already too late, when the machine is already broken. We are used to spending most of our resources on fixing what's broken rather than trying to prevent the breakdown much earlier, more effectively, and at lower cost. Requests for life extension are still considered somewhat arrogant. Many people are convinced that when they reach a certain age, they will want to die, and the idea of completely abolishing death scares them a lot. Ending biological aging would not mean ending death. This can be compared to a childhood game outside in the evening, when you wanted to extend playtime and stop the sunset. Although the talk about playing forever ends when the body starts to feel tired, and you basically don't want to play anymore. If we could imagine a world without illness, aging, and death, how would that affect us in just 100 or 200 years? If we knew we would live longer, would we take better care of our planet? If you could work for 150 years, how much time could you spend searching for something you love to do? How many years could you devote to education, starting a family, and so on? Would this external social pressure and the feeling of stress that every other person on our planet experiences disappear? Or would it get worse? I'll ask again. If you could choose right now how many years you would live in good health with your family and friends, what would your answer be? What is the ideal future for you? Your future directly depends on your thoughts and actions.